I made Genesis as a little portfolio project and it got a huge response from the communities. I posted about the Genesis on several Reddit threads and Blue Sky. So I thought I should do a little tutorial on how to use Genesis, kind of an introduction to the software. When you first open the Genesis, it shows the info tab here, and looking at the window, there are three main panels. When I developed the simulation, I named them as the control panel and the simulation panel and then the analytics panel. So first, in the control panel, you can see the main buttons for the configurations like starting the simulation or pausing, stopping, and reset the parameters. And here you can see in this window, it shows the speed. You can adjust it from 0 to 10. 10 is the maximum speed the simulation can go, and 0 is the complete stop or freeze. And then here it shows generation number as well as the elapsed time. And from this panel, you can adjust the population sizes. And here it shows the current population and the maximum reached population from here. And we can set the population amount from this spin box, and we can add a randomization. For example, if I say 50 here, it will set up the population as 100 plus or minus 50. So the program can spawn a population number, an initial population number somewhere between 50 and 150. So what I'm going to do is I'm gonna set 10 and keep the parameters as the default values and then hit start. You can see these little blue dots are the food that spawned at first, and then I'm going to pause this for a while. These little dots are like the little organisms, digital organisms, or in this tool I call them units. Those units can be spawned anywhere within this canvas. So depending on your computer's desktop resolution, you can see the canvas. Always take a square resolution size, and for this time it took more than 1000 pixels. The other thing is here below the canvas, you have the console. It prints out all the required info and the parameters and the settings for the program. First you have the date and the details of the parameters. So I set the population as 100 and the randomization value to 10. It shows on the console like this, and the rest of the parameters are the default values. What I wanted to show is here we have the unit spawning started line with the target population of 92. That's because we set the population to be randomized. Here this shows the unique IDs for each unit that is spawned, as well as the parameters like size, energy, sense area, and then the speed, predation level. These are the parameters that shown here: unit size, max energy, range, sense range, movement speed, and the predation level. Here in this graph, you can see it can plot those 5 parameters in a line graph. Below that, this shows the real-time trade distribution, which is the average number of each parameter considering the size, energy, predation, sense, or the speed. When you scroll all the way down to the final level, it shows unit spawn 92, which was the amount that we saw in the earlier print. And here you can see the trade averages. These averages are plotted on this radar graph. Okay, I'm going to resume the simulation, and here you can adjust the speed. I'll adjust the speed to 2, so it goes twice as the speed as it started. Here you can see the population growth, generation time increases or decreases. Whatever happens with the simulation, it plots here, and then the traits evolution in this window. I'm going to stop and preset the values of simulation, and then I'm going to do some adjustments. For example, for the unit size, I'm going to set for 200 and max energy to 50, and sense range is okay. Movement speed 100, predation level is 50. That's fine. I'm going to change the randomization value to somewhere like 40. So that means this spawns units that may be randomized the predation level from 10 to 90. That means a unit can predate on another unit if that size is below its size multiplied by the predation level. And the other parameter is you can turn on and off the trade-off values. So what are the trade-offs? When you bring your mouse to the predator parameter, it says some parameters have a trade-off, such as max energy increases with the body size, as well as when the body size increases, it decreases the sense range and the movement speed. Here you can customize threshold for the reproduction. It's like how much energy costs from parents to produce an offspring at the end of the each generation. 80 means if the parent has 100 energy at the end of the generation and the reproduction threshold is set to 80, that means if the maximum energy is 100 and it has already think about like 90 energy, so it can reproduce and make an offspring because its energy level is more than the threshold value. And here the randomized check will do the randomization for the traits when it passes from the parent to offspring. When it's checked, it also incorporates these randomization values to the offsprings. If you uncheck, it will pass the parent traits as it is. It's like doing asexual reproduction, and with the randomization it kind of mimics the sexual reproduction. And considering the energy drain here in this one, it for the reproduction it costs from the parent 60% of its energy, and for the movement drain, this is sort of a threshold value again, and you can change between 0 and 10, and you can go more than that, but it will decrease the capacity to thrive in the environment. And here in the last parameter section, you can change the food supply. The amount is the initial spawn amount, and then you can add the increment or a decrement. When you check the hold, what it does is it always keep a constant amount of food on the canvas at the end of each generation cycle. It's like if there are 10 food on the canvas, and after the generation, if the units eat 5 food, turning on the hold will spawn another 5 food randomly on the canvas. If you uncheck it, it just spawn 10 food randomly on the canvas. And you can hold the maximum amount and set up from these spin box and set up the minimum value from this mode. And the other thing I want to mention is here you can search for something in the console, but the console only prints 1000 lines. I did this limitation because otherwise if we going to load all the text onto the console, it will crash the program. So what I did was, now the console is cached into the system. You can either export to somewhere as a text file, or you can enable writing or like auto saving to a text file. You can pick the location you want to save the file and write give it a name and then click save, so it will auto save to a location. Here I'm going to, okay, let's keep this as it is and maybe increase the food a bit to 20, and for the sake of this tutorial I'm going to increase to the maximum speed of 10, and then I'm going to start the simulation. So these red colored ones are the more carnivorous ones, like they have like a big predation threshold, and the greener ones are the herbivorous ones. They are the intermediate colors are mostly the omnivorous ones that can eat both food and 50% of the body size. So as we can see in this population growth graph, population suddenly decreased after the fourth one and then kind of went through a bottleneck and the trade. This is the most interesting graph in this entire simulation. The sizes, as I increase it to 200, it goes up, and since the trade-offs are enabled, you can see both energy and the speed rapidly decreased with the time. You can see here in these ones, see there are both red and green ones that are very slow and but very big compared to the initial spawn one. So what I'm going to do next is I'm going to limit the food supply to 10 and to wave it properly, let's say. And in the radar graph, you can see the current reproductive cycle makes more bigger. That's because the radar graph goes toward the size, and with offsprings are less sensitive, has less sense area as well as speed. So the other thing we can notice is this is kind of growing after the bottleneck. It's like it drops all the units that are not adapted to this environment, and it got a very little population here, and with this bottleneck it kind of started maintaining their traits and making new offsprings that looks very greenish in color. It's like they are consuming only food. I think you might get a basic idea about the Genesis simulator from this tutorial. And in the meantime, I will try to bring some more tutorials about how to simulate population bottlenecks, extinction events, and how to bring a population to carrying capacities. Till we meet again, bye.